Hello and welcome to viewers of Sriman Narayan Physics. My dear students, today in this video lecture, I am going to describe to you people about the cylindrical capacitor. प्यारे बच्चों, आज के इस वीडियो कार्यक्रम में हम सिलिंड्रिकल कैपेसिटर के बारे में तुम्हें जानकारी देने जा रहे हैं, जहां तुम देखोगे कि एक सिलिंड्रिकल कैपेसिटर किस तरह से अन्य दूसरे प्रकार के कैपेसिटर से डिफर करता है. In what manner a cylindrical capacitor differs from other type of capacitors, and what is the formula for the capacity of a cylindrical capacitor. So let us start. A cylindrical capacitor, it is consisted of two hollow coaxial conducting cylinders. You can see there are two cylinders. This is the first cylinder and second one, it is this cylinder. These two cylinders are hollow and both are collinear. Means that these two are cylindrical cells. Both cells are made of conducting materials and both have got the same axis. That's why I am telling you it is consisted of two coaxial hollow cylinders. Charge is given to the inner cylinder. You can see this is the inner cylinder, and suppose positive charge plus q coulomb of charge is supplied to it. See here, and let us imagine that radius of the inner cylinder is a small a. I mean to say that this is the axis, the radius is a, that is this distance is a, and the radius of outer cylinder, let it is a small b. Now it is quite obvious that on the inner surface of this outer cylinder negative charges will be induced. You can see from the figure it is clear that यह जो बाहरी सिलेंडर है, इस बाहरी सिलेंडर का जो अंदर वाला सतह है, इस अंदर वाली सतह पर नेगेटिव चार्जेस इंड्यूस्ड होंगे. इट इज क्लियर फ्रॉम द फिगर. और इस सिलेंडर का जो बाहरी सरफेस है उस पर प्लस पॉजिटिव चार्जेस इंड्यूस्ड होंगे. चूंकि इस बाहरी सिलेंडर को हम अर्थली ग्राउंडेड कर देते हैं, यू कैन सी इट इज क्लियर फ्रॉम द फिगर, द आउटर सिलेंडर इट इज earthly grounded. So the wholesome induced positive charges will be neutralized by the earth. So we have got the plus q charge and minus q charges, which are the induced charges. Let the surface density of charge for this inner cylinder, it is plus sigma, and for this cylinder it is minus sigma. Also consider that you can see radius of inner cylinder, it is a small a, radius of outer cylinder, let it is b. Surface density of charge, surface density of charge for inner cylinder, let it is plus sigma. Charge given to the inner cylinder, it is plus q coulomb. Length of the cylinder length of the both cylinder, it is a small l. So the value of surface density of charge sigma, that must be equal to Q by L. Now we are going to consider an observatory point P. You can see here from the figure. This point, this is the observatory point, and let this point is P. Now this point P is located at a distance x from this axis. Now this inner cylinder will behave somewhat like that of a line charge distribution. And you know, if you have got a line charge distribution, then at a distance x from the line charge distribution, the value of electric field intensity, it is given as E equals to lambda by 2 pi epsilon naught into R. So since this is the linear density of charge lambda, not it is linear density of charge. Linear density of charge is lambda, and just imagine the electric field intensity at the point P, that can be given as E equals to lambda by 2 pi epsilon naught into x. क्योंकि एक लाइन चार्ज डिस्ट्रीब्यूशन की तरह ये बिहेव करेगा, और जैसा कि मैंने बताया कि इसके लिए लीनियर डेंसिटी ऑफ चार्ज की वैल्यू लैम्डा है, तो स्वाभाविक सी बात है कि ये जो पॉइंट P है जो इससे x दूरी पर है, यहाँ पर जो इलेक्ट्रिक फील्ड इंटेंसिटी की वैल्यू होगी E बराबर लैम्डा बाई 2 पाई एप्सिलॉन नॉट इनटू x होगा। अब हम क्या करते हैं कि इस पॉइंट P पर एक यूनिट पॉजिटिव चार्ज को प्लेस करते हैं। सो लेट अस प्लेस अ यूनिट पॉजिटिव चार्ज एट द पॉइंट P, और यदि इस यूनिट पॉजिटिव चार्ज को पॉइंट P पर प्लेस करें, then in that very situation the unit positive charge will experience a force, and that force will be given as F is equal to charge multiplied by electric field. The charge is unit, so we'll write 1, and the field is capital E, and this is equal to lambda by 2 pi epsilon naught into x. So this is force. Now due to this force, the unit positive charge will tend to move towards the inner surface of outer cylinder, since the inner surface is negatively charged. So just imagine this unit positive charge moves through a very small distance dx towards the inner surface of outer cylinder. So in this way some work will be done. That work done is said to be elementary work done. So let us try to calculate what will be the elementary work done. So elementary work done dW, it must be equal to F into dx, and it is equal to lambda by 2 pi epsilon naught into x into dx. You can see here from the figure, it is clear. Now if this unit positive charge starts to move from this point to this point, that is from outer surface of first cylinder to the inner surface of the outer cylinder, then in that very situation the total work done can be given by integrating this function. So we'll write total work done W, it is equal to integral A to B, and this will be equal to lambda by 2 pi epsilon naught into x into dx. Let us now try to solve this relation. We can write here we'll write W is equal to how much? Lambda by 2 pi epsilon naught integral dx by x, lower limit A, upper limit B. And you know dx by x, the integration of dx by x, it comes log x. So we'll write this work done equal to lambda by 2 pi epsilon naught into log of x at the base e. The lower limit b, upper limit will be a. Now next you can see this will be equal to W, and this W will be equal to lambda divided by 2 pi epsilon naught, and it will be, this will be A, lower limit, upper limit will be B. So we will write log of B at the base E minus log of A at the base E, and this can be written as lambda by 2 pi epsilon naught into log of B by A at the base E. Now from the definition you know very well, this work done will be equal to the potential difference between these two cylindrical bodies. So the potential difference, let it is V. So the value of V, it will be equal to lambda by 2 pi epsilon naught into log of B by A at the base E. Now I want to find the value of capacity. What will be value of capacity? See here. The capacity, you know very well, capacity, it is simply given by C is equal to charge divided by potential difference. So we write Q divided by V. What is the value of V? Lambda by 2 pi epsilon naught into log of B by A at the base E. Now lambda, it is equal to charge per unit length. So we write this relation as Q divided by Q by L, since length is L. So Q by L into 2 pi epsilon naught into, here we will write log of B by A at the base E. Q will be cancelled out, and you will get the relation 2 pi epsilon naught into L divided by log of B by A at the base E. So the formula for capacity, it is, we can write here, C is equal to 2 pi epsilon naught into L divided by log of B by A at the base E. This is the required formula for calculating the capacity of a